So number 1 says, the acceleration of a Maserati is proportional to the difference between 250 kilometers per hour and the velocity of this sports car. Right, if you can borrow a Maserati and test this out, let me know. That would be a good time. If this machine can accelerate from rest to from 0 to 100 kilometers per hour in 10 seconds, how long will it take for the car to accelerate from rest to 200 kilometers per hour? Okay, so we begin with the acceleration. What's the acceleration? dv dt. That's the derivative of velocity. dv dt is proportional to the difference between 250 kilometers per hour and the velocity. So we have dv dt is proportional, so that's some number k, to the difference between 250 and the velocity. 250 minus v. All right, and then some more information. It says if this machine can accelerate from rest to 100 kilometers in 10 seconds. So what's that tell you? So at time t, so at time 10, velocity is 100 kilometers per hour. And then it wants to know how long will it take to start from rest and get up to 200 kilometers per hour? Will it be 20 seconds? No, not twice as long. That's not your guess? That's good. Is it going to be less than 20 seconds or more than 20 seconds?
Should be more because depends on how the air resistance of the car is.
My guess is it will be more than 20 seconds.
Because the faster you go, the more air resistance you have.
Because that's exactly right. The faster we go, the more air resistance we're going to. This is basically your air resistance right here. Your air resistance is proportional to how fast you're going. So the faster you go, the harder it's going to be for the car to accelerate. So my guess is it's going to take more than twice as long to get up to twice the speed. That's my guess. But we'll see. Okay, how do you solve that differential equation? What kind of equation is that? That is separable. It's also linear, but I think I'll solve it as separable. dv over 250 minus v equals k dt. Integrate both sides. What's the integral of dv over 250 minus v? Negative ln of 250 minus v. That's right. That's really a u substitution problem. You're letting u equal 250 minus v. So du is minus dv. That's where that little minus sign comes from. Equals kt plus c. (250 minus v is minus kt plus c with an ln.
Either you've got an E on the right-hand side or...
Now I'll put my E on the right. I was going to do it both in one step, but then I changed my mind halfway through. 250 minus v is c e to the minus kt, which means v is c e to the minus kt plus 250.
Minus 250 because you have negative minus.
I would subtract the 250, but then I've got to multiply by negative 1. So I got two negatives there, which make that a positive 250. Now what? Problem is I've got two variables. I've got a c and a k.
Oh.
Find the C first. How am I going to find C?
Yeah.
Plug in 0 for t. So that's an initial condition we didn't write down. If we plug in 0 for t, what's our initial velocity? 0, because it told us we were starting from rest. So we actually need another initial condition. Be it 0 is 0. So I think I'll start with that one. When I plug in 0, I get 0 equals c plus 250. So v is minus 250, e to the minus kt plus 250. Then I plug in my other initial condition. V at 10 is 100. 100 equals minus 250 e to the minus 10k plus 250. Subtract the 250. Where'd the k go? The k's still there.
Oh.
I plugged in 10 for time. I just wrote it as minus 10k. K's still there. Divide by negative 250. Let's see, that's 15 over 25. I can divide by 5, that's 3/5. Equals e to the minus 10k. So ln of 3/5 is minus 10k. K is negative 1/10 ln of 3/5. All right, so now I'm ready to answer the question. The question is, when will the velocity be 200? I'm going to have 200 equals minus 250 e to the minus 1/10 times ln of 3/5 times t plus 250. We solve that equation. We subtract the 250, that gives us a negative 50 over there. Then we divide by negative 250. Negative 50 divided by negative 250? 1/5. 1/5 equals e to the minus 1/10 ln e to the ln of 3/5 t. So ln of 1/5 equals negative 1/10 ln of 3/5 t. T is, grabbing my calculator, ln of 1/5 times negative 10 divided by ln of 3/5. Somebody made a mistake.
When we
Because I got t equals negative 31. Go ahead.
When we multiply by negative 1, we're supposed to switch c to negative kt to negative as well.
Well, c is just a number, so if I multiply c by negative 1, it's still just a number.
But the e doesn't. Yeah.
It's that c shouldn't have mattered.
Shouldn't there be a negative sign? Shouldn't it be a negative 10?
Right there?
No, never mind.
Oh, I know where my mistake is. My mistake is right here. K turned out to be a negative number, didn't it? Because it's got a negative there. And then when I plug in, it's got a negative there. So negative and negative, this should be a positive. See, everybody makes mistakes. Even on tests. Yeah, I'm very forgiving for dropping a minus sign. That's not a big deal. But you should also recognize if you get t equals negative 31 seconds that you made a mistake, and hopefully you'll go back and look for it. So, time traveling?
See, in physics, we just go, it's not the direction we want, just take it.
Make it yeah. So it takes a little more than 3 times as long to get up to twice the speed. That was number 1. Little old number 1. Questions on that one? All right, let's try one more out of the book. Number 7. Number 7 says, suppose that a car starts from rest, its engine providing an acceleration of 10 feet per second squared, while the air resistance provides 0.1 feet per second squared of deceleration for each foot per second of the car's velocity. Part A, find the car's maximum possible velocity. And part B, how long will it take for the car to get up to 90% of its maximum velocity?
How far will it travel?
No, it doesn't ask how far does it travel after the engine blows out. It doesn't ask that question. Would be another good question, though. Find how long it takes. Oh, and how far it travels. Okay.
I was going to say, it says so in my
It says so.
book,
Oh, yeah.
so-
All right. That's easy enough. We'll figure that out, too. All right, so what do we know? Suppose that a car starts from rest. B at 0, 0. Its engine providing an acceleration of 10 feet per second squared.
Wouldn't that be the wouldn't that be the derivative?
dV dt is acceleration, so we know dV dt is 10 feet per second squared, while air resistance provides 0.1 feet per second squared of deceleration for each foot per second of the car's velocity. So minus 0.1 v. So this is very, very similar to the previous problem. The difference is, in the previous problem, we needed to figure out that number. In this case, they're telling us that number is simply 0.1. Okay? And then we want to find, part A, the car's maximum possible velocity. All right, well, seems as though we should be able to solve. What kind of equation is that? Separable and linear. But we'll do separable, all right. dV divided by 10 minus 0.1 v equals 10, equals 1, equals dt. There we go. Kept changing my mind there. We integrate both sides. What's the integral of 10 minus 0.1 v? Negative. All right, so we're going to have to let u be 10 minus 0.1 v.
You are right.
So du is minus 0.1 dv. So I need to sneak in a minus 0.1, which means I need to balance that with a 1 over negative 0.1.
Wait, so negative 0.1 is just a negative 1 over 10. So it's 1 over negative 1 over 10. So it's just negative 10.
So this number right here is the number negative 10. That's right. So I have to put in a negative 1/10, which means I need to balance it with a negative 10. Absolutely. So we're going to have negative 10 ln of 10 minus 0.1 v equals t plus c. Divide by that negative 10, then exponentiate. ln of 10 minus 0.1 v is negative 1/10 plus negative 1/10 t plus c. Exponentiate 10 minus 0.1 v is c e to the minus 1/10 t. Minus 0.1 v is c e to the minus 1/10 t minus 10. And then finally I divide by negative 0.1, but dividing by negative 0.1 is the same as multiplying by Negative 10, so I multiply everything by negative 10. V equals C e to the minus 1/10 t plus 100. Plug in my initial condition. I get V equals C plus 100. So C is negative 100. All right, so there's my equation. V equals negative 100 e to the minus 1/10 t plus 100. All right, so part A. What's the maximum velocity of this vehicle? Let t go to infinity. As t goes to infinity, what happens to this? A very large negative number. And e raised to a very large negative number gets very close to 0. So 0 plus 100. So the maximum velocity is 100 feet per second. Part B says, find how long it takes to attain 90% of its velocity. So 90% of 100 would be 90. Equals minus 100 e to the minus 1/10 t plus 100. Subtract the 100, we get negative 10. Divide by negative 100, we get negative 1/10. Shows up again. Common little number in this problem. So negative 1/10 equals e to the negative 1/10 t. Oops, that's positive 1/10, right?
Yeah, I was going to say, because we can't take a natural level of a negative number.
Right, because we subtract, we get negative 10, then we divide by negative 100, that's positive 1/10. ln of 1/10 equals negative 1/10 t. So t is ln of 1/10 times negative 10. We'll call it 23 seconds. I got 23.025. We'll just call it 23 seconds. All right, and then there's one more question. The last question is, how far do you go if you drive for 23 seconds?
Let's use t in the
1/2 at squared formula. That formula for 1/2 at squared works as long as your acceleration is constant.
Acceleration is constant, 10 feet per second.
Minus, our acceleration is not constant. Our acceleration is, where did it go? Way up here. Our acceleration is 10 feet per second minus 0.1 times whatever our velocity is. Our acceleration is not constant.
Integrate the velocity.
You have to integrate the velocity to get position. That's correct. So position.
Type of acceleration problem on the test.
Yes, there will be this type of acceleration problem on the test. It's only two parts, A and B. No, this is part B still. There was no part C. The book didn't break it up as a part C. There's no part C. We integrate again. What's the integral of negative 100 e to the negative 1/10 t? Because when you integrate e to a power, you're going to have e to the power, but then you divide by whatever this constant is. So I'm going to take negative 100 and divide it by negative 1/10. That gives me 1,000. Plus, what's the integral of 100? 100t. And then plus some number c. I don't want to use c because I already used c. I already used k.
L.
L. Okay.
Or S0.
What's that?
Or isn't that the initial position?
Again, that initial position thing only works as long as your acceleration is constant.
So physics is going to trip us up here.
Physics is going to trip you up here. I think what we need to do here is we need to plug in s at 0 is 0. So we get, when we plug in 0, we get 0 equals 1,000 plus 0 plus L. So L is negative 1,000. Finally, we plug in 23. S at 23 is going to be, I have 1,000 times E raised to the negative 1/10 times 23 plus 100 times 23 minus 1,000. The car went 1,400.3 feet approximately. Questions on that? If I were to put a problem like this on the test, the directions would probably, much like I said for that one, with the mixture problem, for the mixture problem I said your directions will just be find a formula for the amount of salt. The directions here would most likely be find the formula for velocity.
Okay.
So you would stop at that point.
Not part A, part B with it.
Okay? So, and once you find that function, you've done the differential equations. The rest of it after that is all stuff you should know from algebra. So it's the differential equations that I want to check. So I would have you stop right there,
All right.
which saves you a good 5 to 10 minutes.
10. Checking for mistakes, going over it again. Being wrong, but checking it again.
Other questions?